Hello friends! Today I'm going to recap this 38-year-old Apple Hard Disk 20 using my brand new Hakko FR301 desoldering gun. This video is part 1 of a 2-part series. Apple released the HD20 in 1985, and I'm happy to report that it still boots my Macintosh 512KE today in 2023. But because the fluid-filled electrolytic capacitors are so old, we still need to replace them. Disassembly isn't hard, it's just a time-consuming task. We'll start by flipping him over so that we can remove the single screw on bottom using a Phillips plus head screwdriver. Yours might be a Torx T15, so please keep that in mind. Now we need to flip him back over to remove the top. Removing the top lid is tricky because there are little plastic tabs on either side of the case that latch it down in back. You can just barely see that tab right in this area behind the outer plastic. So what we have to do is very carefully take a minus screwdriver and we have to push inward on it. Not too much, otherwise you'll crack it off, and you don't want to do that. But we have to push inward on it in order to lift this lid up. So I'm going to start on one side and push gently inward on that tab. And you can see I pulled it up on this side. And then I need to do the other side. Now inside we see two things that need recapping. The first is the Rodime Model 522 20 megabyte hard drive and the Sony power supply, which sits directly beneath this controller board. We don't have to recap the controller board because it only has tantalum capacitors on it. Recapping switching power supplies can be tricky, so I'm going to recap that in my part 2 video. Today I'm only recapping the Rodime hard drive. Now you might be wondering why I don't swap out this ancient Rodime hard drive for a modern SD card solution like a Blue SCSI version 2. And the answer is the Hard Disk 20 is not a SCSI drive. You see, Apple designed the HD20 to attach to the Macintosh 512K's external floppy drive connector. And it also works on other Mac models too, but only when attached to their external floppy drive connector. Mac GUI has an interesting article about a SCSI-based replacement controller board for the HD20, but even if someone were able to recreate that SCSI controller, you then couldn't use the Hard Disk 20 anymore on your Macintosh 512K or 512KE because they don't have SCSI. If you want a modern recreation of the Hard Disk 20, I highly recommend the FloppyEMU, which has a Hard Disk 20 mode. Another option is the Tash20, which is a cheaper and smaller Hard Disk 20 replacement that's really neat. But it's more fiddly than the FloppyEMU because the Tash20 uses an HFS formatted SD card that modern Macs can't read. Now bear in mind that all of these replacement devices for the Hard Disk 20 will be the same slow speed as the Apple Hard Disk 20 because all of them connect to the Mac's floppy drive connector. Removing the drive requires us to take out the entire metal tray that sits beneath the drive and the power supply. To do that, we must first lift up and remove our main cable here. And then we need to remove the two screws that are on either side of the stock fan. And by the way, this fan is the Elena brand. It's extremely loud, and that's why I added this in-series resistor. And it made it much quieter, but the disadvantage of using the resistor is that it reduces the airflow. So later on, I plan to swap out this fan with a much quieter Noctua. Now with the screws removed, I just need to slide the bottom tray forward because there are some plastic hooks up here. And it moved it forward. And now I just lift up and carefully and very slowly, so you don't crack any plastic, pull it out. Next, I will remove the ribbon cable from the controller board. Now I need to flip this entire tray over very carefully. You don't want to damage anything when you do that, because on the flip side are the 4 screws which hold the drive in place. And I'll go ahead and put some bubble wrap under this drive, just because I don't want it to drop down onto a hard surface when I remove these screws. Now on the bottom of the drive, we can see the 8 electrolytic capacitors that we have to replace. 2, 4, 6, 8. And in order to desolder these capacitors, we're going to have to separate this circuit board from the drive mechanism. And to do that, we have to remove 2 screws here, 2 screws here, this connector, and this connector at minimum. Keeping in mind that there are 2 very thin ribbon connectors on this side. We don't necessarily have to remove them, so I won't right away. Well, I changed my mind, and it's important to remove these 2 ribbon connectors, so I've been slowly, very carefully prying them with my fingernail, and then getting a little negative screwdriver in there will help to pluck it out. You definitely don't want to break these ribbon connectors. And this one seems to be attached with a little bit of glue. It comes right off. Before desoldering, I'll give you an unboxing and general overview of my Hakko FR301 desoldering gun, which I purchased here in Japan. As you can see, it comes in a very durable, light gray color, hard plastic case. Opening it up, we see that it contains the desoldering gun and a tiny metal stand. We also see it contains 2 cleaning tools, and it contains paper filters, 2 pieces, and also contains a metal filter, and it contains the tip remover tool. The gun includes 1 tip pre-installed with a 1.0 millimeter hole diameter covered by solder. Now there were 2 models of the FR301 sold on Amazon Japan, and I chose the slightly cheaper one, which has the 2-prong power cord on it. A 3-prong version was also available, but Japan is notorious for not having 3-prong outlets in homes, so I just went with a 2-prong plug. The neat thing about the FR301 is that the suction pump is housed inside the handle itself, unlike old desoldering stations, which have a separate pump. Now, in theory, the built-in pump should increase the sucking power, but I'll find out later if that's true or not. The sucked out solder goes inside this transparent little cylinder here, and to take him out, all we do is just push it back till it clicks. Then we can pull it right out. We see there's a paper filter at back here, and then there's also a metal pre-filter before that. And of course on this side, that's where the hole is, where everything goes inside. And it's very easy to just put him back on by pushing this yellow button, and it clicks back into place. And this little tool makes it very easy to change out the nozzles. We just put him on and twist, and pulls right off here. We can see there's our 1.0 millimeter stock nozzle. Now I also purchased another one, which is 1.6 millimeters, and these are nice for wider pins, something that's a bit wider than normal that you may need to suck out. And there's even some that have much smaller holes in them too. I also purchased an optional filter pack, which is nice because the filters get dirty fairly often, and this helps keep your device clean. Now the power switch is found right here, and then pressing the trigger marked vacuum is what engages the pump. And then there's an LED light here on front, which is going to light up and show you when it's ready to be used. And then at the very bottom, this little yellow guy here allows you to adjust the temperature anywhere from 350 degrees C all the way to a super hot 500 degrees C. Now the manual says to set it on 1 for single-sided PCBs, set it on 2 for through holes, set it on 3 or 4 for multi-layer PCBs. And there's even a little twistable potentiometer here so that you can calibrate the gun itself if ever you find that the temperature is different from the marked temperature. So here we have our desoldering setup. Because the PCB is not single-sided, I'm going to change it from the current 1 setting to 2, which the manual says is recommended for through holes. And that's going to increase the temperature to 400 degrees Celsius, 750 degrees Fahrenheit. And now, if I turn on my tool, the LED is lit. And it says it may take up to 60 seconds, and then when it starts flashing, then the tip will be heated to the temperature I just set. Okay, now seems to be flashing slowly, so we're ready to get going. And we can start with 2 of the 47 microfarad capacitors, and it's nice because the leads on these are perfectly straight, they're not bent. Well, as we can see here, on this one hole, it seems to suck out all the solder, but these 3, it did not, so I need to add solder and try it again. Oh, one of them fell out. The other one... Yep, he just needed to be wiggled. And he's out of there too. So sometimes you just need to add a little solder. Now I will take out these 2 in this corner. Okay, so just like before, we need solder on it. That one came out. Small little one. The other one, check in with my lens. Oh, here he goes. All right. So next, it doesn't matter what the order is. I guess get this guy here. And unfortunately, this is one of those PCBs that is not marked on the bottom. So it takes a little bit more effort to figure out which one it is. So this guy, I believe I've identified him. What I could do is just start off by adding solder. That might actually be a better idea. Nope. Still has a little bit more. Yes, there he is, came right out. Okay, so now we've got 2 guys up here. They're pretty easy to identify those. Should be removable now. Yes. And yes. Great. And so then we've got another one over here. Maybe. Yes, pulled right out. And that's all 8. So now it's time to put in our new capacitors. And again, the Mauser card is in the text description. And the little helper I gave you before, I just printed it out for myself. It also tells you the plus side, and the circuit board tells you the plus side too. So you really won't screw up if you go by that. Just make sure that you have the minus side, the stripe side, that's negative. So you don't have it opposite the plus. And then you'll be okay. And I'll just do them one at a time. And that way I can hold it in by pressing it with my finger and then just apply solder. Put a little flux on it. Now flip him over and make sure he's straight, sitting flush with the board. So now, because of that, I can snip off the excess. And then I can put in my next 47 microfarad. Make sure I get the polarity correct. Plus side over here. Stripe side opposite that. Add a little flux. And after cleaning off all the flux, we can see, maybe I put a little bit too much solder over here, but it's making contact, so I'm just going to leave it that way. So, okay. Next, we've got a 10 and a 47, which will go in these holes respectively. Oh, I soldered it in before I turned on my camera. But you get the picture. I applied flux and then put my solder on. Now put in the 47. Another 47, except the plus goes this way, opposite to the others. Now we've got our two 10 microfarads with the plus going that way. And last but not least, our final 47. Here's the fully recapped board. And I used 100% iso alcohol to clean off all of the flux on the back. Now my replacement capacitors are 5.0 millimeters in height to match the stock capacitors, but technically speaking, you don't have to strictly abide by that if you don't want to buy my Mauser card. As you can see at left, there's this yellow tantalum capacitor. Most of the tantalum capacitors are much taller than the electrolytics, and that's because the board is raised up off of that metal plate in the HD20. So in a pinch, you can buy 7 or 8 millimeter tall electrolytics and they will work just fine. Now before I put the controller back on the drive mechanism itself, I want to say a few words about oil. First of all, my drive worked fine prior to recapping, and in a few minutes we're going to see if it still works fine after the recapping, but I am aware that Adrian's Digital Basement had a video on where he oiled stepper motors on some of his drives.
Here we go, there's another drop of oil, and most likely if I operate the drive like this, it'll help the oil kind of penetrate down.
But he never did this particular drive, and he said it was beneficial, and after more than a year he hadn't had problems, and I understand all that, but I'm still a little bit hesitant about it, even though I also know that Dog Cow, who owns the Mac GUI website, he has a great HD20 page on there. By the way, this is David Finnegan I'm talking about. He's the author of the new Apple II User's Guide. He had mentioned that he had put up to 2 drops of oil on the stepper motor point here, and he also put oil on this ball bearing here. And I still sent him an email about this just to confirm, because I wanted to make sure, and I asked him some questions, and he replied back to basically say what his blog said, but he hasn't replied back again to answer my question more specifically. And this ball bearing, the purpose of it is to make contact with this little pad here. It's an anti-static grounding pad. And so my thinking is, if I put oil on here, even if it sinks down inside, well, I'm going to flip the drive over and gravity's going to pull it down, so wouldn't oil get on this pad and kind of interfere with that anti-static ground connection? That's my worry. Also, when I move this ring, if I take my lens and look at it really closely, I can see that this ball bearing moves too. So would the oil really get down there and do any good? I'm not so sure. Now maybe on this point it would, but I haven't taken this apart. I didn't want to mess anything up, so I haven't taken it apart. And I'm just, it's working fine now. Whenever you oil something, it gets gunkied up inside and it attracts dust, and so that's my concern. Even though this will be flipped over, let me know your thoughts down in the comments. I can always open this back up again and add oil if necessary, but it's working fine now. Sometimes if it ain't broke, don't fix it, although that doesn't apply to capacitors, but maybe in this case it does. Should I really apply oil? I have my Super Lube synthetic oil with PTFE, which is some really great oil I've used to lube floppy drives with, and I could easily put it here and here, but I'd like to hear your practical experiences, not just your speculation, but if any of you have actually oiled this particular Rodyme drive in the HD20, not only at this point, but also this point too, I'd like to hear how long that's been going on and if it caused any problems or anything like that. So I will start by putting him back in the exact order that I took him off. And that means we have these little connectors here. They're very fragile, at least the ribbon cable part is, so just be very careful when putting them back on. Should probably get this guy up here first. So he's seated in there, and then it would be a good idea to put them on. And they should just slide in pretty easy. And this had some glue on it, probably because the thinking was that this is a plastic connector, it's only 4 pins, it might slide out, but I'm not going to add any new glue because I might take it off again, right? It seems fairly secure, so I don't think I need any new glue in there. And then I should probably put in this screw before I put that connector down. And of course, don't screw the screws back with all your might. This is a circuit board, so you don't want to crack it. Now you'll notice something about our enclosure. The fan looks different, and that's because off camera I swapped it out for this Noctua. I'll put this down in the text description for you. And I twisted the wires. You know, you should always do this to prevent noise. And I also twisted this part. This red and black is the stock part. And then I used heat shrink tubing to splice the two together so I could retain this connector. And well, it's going to be using the same 12-volt power source, so it should give me lots of airflow, but much quieter than the stock fan. Now, what I'm going to do is put something soft in here so I can put my drive like this. I'm not going to mount him. I don't want to take the time to do that because we're just doing a quick test now. And I'm going to just connect the ribbon cable to the controller board and then connect it to the drive like that, and then just put him like so nothing is shorted here. And I'm not going to connect it to the Mac. I'm just going to connect power, and then we'll switch him on and make sure that he is spinning up. And then once I confirm that, I can connect him to the Mac. Okay, I've got my power cord in there, so let's power him on. Okay, everything sounds good. My Noctua is blowing, as it should, making all the normal sounds. Well, now it's time for the final test, where we see if my newly recapped Rodime hard drive will boot my Macintosh 512KE again. Now, I have high confidence that it will because we just completed the spin-up test with success, but we nevertheless need to do this test just to make sure. Now, what I'm going to do is I'm going to first spin up the hard disk 20, which will take at least 10 seconds, and that's according to the hard disk 20 user guide. Initially, when you power on, you'll see this LED flash, but when the LED stops flashing and lights solid, then that tells you it's safe to switch on the Mac. And because I'm not able to see my Mac screen like you are, I'm going to use my iPhone here because my iPhone is wirelessly connected to my camera, so I can see what you're seeing and determine if it's actually booting the Mac or not. So let's get started by switching on the power here. Okay, and you can see, I don't know how easy it's going to be for you to see, but I can see it from the back of the drive that the LED is flashing. And this fan, Noctua fan, is quieter, by the way. So it's quite nice, and it provides really good airflow too. So, okay, it's stopped now. I'm going to turn on the Mac. Okay, we got the bong. I don't hear anything yet. Okay, there we go. And looking at my iPhone, I see what you're saying. Hey, welcome to Macintosh. It's booting. So we have a resounding success today, folks. Now, in the text description below, I have put for you the link to Amazon for this fan. And I have also put a link to Mauser. It's a Mauser cart of all of the capacitors that I used to recap this Rodime hard drive. Now, please stay tuned for part 2. And actually, I would recommend that you don't buy the Mauser cart yet until you have watched part 2, because I highly recommend that you also recap your Sony power supply, not just the drive only. And the reason I haven't prepared that Mauser cart yet is because many times switching power supplies have issues if capacitor ESR is too low. And because I'm not the designer of this power supply, I don't have a schematic or anything like that, it's kind of a shot in the dark when you replace capacitors. So I bought more capacitors than I actually need, some with low ESR and some with higher ESR, so that if I need to, I can swap them out and find the right ESR balance. And I learned this for the first time when I recapped the Apple HD20 SC, the SCSI equivalent of this hard drive, which came out a number of years after the HD20. And I found that there was one capacitor in particular that I had a somewhat low ESR replacement capacitor in there, and it became unstable, and it made a beeping sound. And when I swapped that low ESR capacitor out for another capacitor which had higher ESR, then it started working fine. So it could be that I might have to go through a little troubleshooting like that when I do my next video. Anyway, please stay tuned for that. And in the meantime, please let me know your thoughts down in the comment section below. Specifically, I'd love to hear your own experiences with the HD20. Do you have an actual HD20 like I have? Do you have a FloppyEMU? Do you have a Tash20? Please let me know. And especially those of you who have lubricated your Rodyme drive before, not only the stepper motor, but also that ball bearing in the middle of the spindle. I would love to hear your experiences on that. It's not that I don't trust David Finnegan, who's Dog Cow. I do, but there's really not a lot of people. I basically, Googling this topic, found him and one other person who's actually lubricated this particular drive. And yes, I trust Adrian's Digital Basement, but I'm talking about this particular Rodyme drive. So please let me know your personal experiences about lubrication. Thank you for watching today, folks, and I wish all of you a wonderful week. Bye-bye.